Okay, we're going to do a few out of exercise 4.1, and that's in your textbook on page 166. And it's a few derivative examples using e to the x. So exercise 4.1, and I'll choose one to do. Let's have a look at question 3a. So y equals 9 e to the x is how I'm setting it up. That way I can then say that y dash equals, or I could use dy dx. We just got to get our notation to look good. So we know whenever we have a constant in front of a function, the constant comes out the front. So we can say that it's 9 times the derivative of e to the x. All right, that 9's come out the front. So let's carry on with that, and we know that the derivative of e to the x is simply e to the x. So that's a fairly basic one. Let's have a look at, we'll look at e. And we have, and I'll set up the notation slightly differently so you get used to seeing how it is. So I'm going to have d by dx of e to the x plus 1 cubed. So I can now say that that's going to be, using the chain rule, I'm going to deal with the outside function first, and that's the cubic. So when we do the derivative of a cubic, the 3 comes down the front, and it just dropped by 1 power. So it comes down to 2. And then I'm going to go inside into a smaller level here and have a look at the function that's inside the bracket. And the function that's inside the bracket is e to the x plus 1. So we're now going to do the derivative of that one. You could do that all in one line if you like, but I'm sort of just making a point here. So here we go. Because the derivative of e to the x plus 1 is simply e to the x. And just to be tidy, I'm going to bring that e to the x out the front. Okay, so that's e. So that's basically the chain rule. Let's do one where it's product rule. So I've got a product rule in H, and I'll set up my notation slightly differently again. So I will say that y equals x e to the x, and now I'm going to find dy dx, and using our product rule, it's the first function times the derivative of the second function plus the second function times the derivative of the first function. I can then factorize that one, and I'm going to pull out a factor of e to the x and be left with x plus 1. So there's a few to get started.